Hey everyone, Mr. Markwick here. In today's tutorial video, I'm going to show you how to add and subtract algebraic fractions. An algebraic fraction is basically just a fraction, but there is an algebraic expression or term in the numerator or the denominator. Now, some of these next two dot points are similar when we're adding and subtracting fractions that aren't algebraic. The lowest common denominator of two fractions, in this case algebraic fractions, is the smallest number that both denominators are factors of. And when we're adding and subtracting fractions, again, in this case algebraic fractions, the fractions must have the same denominator. Okay, so here's an example. 2x over 5 plus 4y over 5, they can be added because they have a common denominator or the same denominator of 5. In the case of the numerators, though, in this case, they can't be added because they're not like terms. So probably not the best example. But the first example I'm going to look at here actually can be simplified because we'll look at it in a second, but both the numerators are like terms. So 3x over 11 plus 5x over 11. They both already have the same denominator, which is 11. The numerator in the first fraction is 3x. The numerator in the second fraction is 5x. They are like terms because they have exactly the same variable, x. So I can add those two together. Now, again, when you're adding fractions, it's simply the numerator plus the numerator, and the denominator stays the same. So in this case, my answer would be 8x, 8x over 11. Okay, numerator plus numerator, denominator remains the same. And it's the same when we're, like I said, adding fractions that are not algebraic. In the second example, you can see there, I might change color because my examples get close together. I've got, again, two fractions, algebraic fractions. In this case, they don't have the same denominator. The first fraction has a denominator of 3, the second has a denominator of 5. So we need to rewrite these fractions equivalent with a common denominator. And remember here, the lowest common denominator is the smallest number that both denominators are factors of. So I've got to think of factors of 3, and I've got to think of factors of 5. So if I wanted, I could start listing factors of 3. So factors of 3, obviously 3, multiples of 3 are 3, 6, 9, and 15. I'll stop there, and you'll see why in a second. Multiples of 5 include 5, 10, 15. So here is my lowest common denominator, 15. So I'm going to rewrite these fractions here with denominators of 15. So 15 is my common denominator, but I can't just write 4a over 15 because to go from a denominator of 3 to 15, I've multiplied by 5. 3 times 5 is 15. So that means I also need to multiply my numerator by 5. So 4a times by 5 is 20a. 4 times 5 is 20, and a remains the same. And likewise, my second fraction, 5 multiplied by 3 is 15. So I need to multiply my numerator by 3. 2a times by 3 is 6a. At this point, my two algebraic fractions have the same denominator of 15. So my answer is also going to have that denominator of 15, and I simply add my numerators. 20 plus 6 is 26, and because they're like terms, 20a and 6a added together give me 26a. All right. Now, don't forget you can simplify fractions. In this case, 26 and 15 don't have common factors, so I can't simplify this one. But if you get to a point, for example, if that was 25a over 15, they would both have a factor of 5, and therefore I could simplify the fraction further. So just be aware of that. You can simplify fractions, and like for my class, we've already done that. So that's a skill that you should already have when you get to your, I guess, your final answer there. All right. Subtracting fractions is the same. The same rules apply, but instead of adding the two numerators, you just obviously subtract them working left to right. In this case, I have denominators of 5 and 10. Again, they're not the same, so I need to change them so they are. In fact, in this case, I'm only going to change the first fraction to have a denominator of, you guessed it, 10. So the second fraction, algebraic fraction, remains 3k over 10. I've changed the first algebraic fraction to have a denominator of 10 by multiplying the 5 by 2, which means I need to multiply my numerator by 2 also. So 6k times by 2 is 12k. And then I can subtract these because they have the same denominator. Working left to right, it's numerator subtract the numerator in this case. So 12k take 3k is 9k over 10. Then we look for, are there any common any common factors between the numerator and denominator? No, there's not, so I can't simplify it any further. In the last example, again, the denominators are not the same, so I have to find a common denominator, the lowest common denominator. But you'll notice actually that the numerators are not like terms, so we won't actually be able to fully, I guess, collect them to simplify them, but I'll show you what that looks like regardless. So first thing we need to do is rewrite these fractions with a common denominator. So what are some multiples? In fact, let's do that. What are some multiples of 6 and 9? So for 6, we have 6, 12, 18, 24, 30. I could keep going, but I'll stop. 9 has multiples, so let's go 9, 18, 27, 36. Whoops. You can see there that the lowest common multiple is 18. So I'm going to rewrite both of those algebraic fractions with denominators of 18. Now, to go from 6 to 18, a denominator of 6 to 18, I multiply by 3, which means I multiply my numerator by 3 also. So a times by 3 is 3a. And to go from a denominator of 9 to 18, I've multiplied by 2, which means I must multiply my numerator by 2. So b times 2 is 2b. Now, I can subtract these fractions. My answer is going to have the same denominator, which is 18, and then I just work left to right, numerator take numerator. Now, as I said at the start of this question, these two terms, if you like, at the top of the fraction are not like terms, so I can't collect them or simplify them. I can't subtract them from each other. So I would actually have to write 3a take 2b over 18. And that would be my final answer. Okay, so hopefully that helps. Like I said, most of the rules for adding and subtracting algebraic fractions are exactly the same as they would be for adding and subtracting normal fractions, except we have, algebraic terms which you collect if they are like terms, add or subtract them. Okay, so hopefully that helps, and thanks for watching, guys.